Algebra 2, Lesson 63, Addition of Vectors. So they're going to give us a word problem. Looks like this. They tell us flying arrow left the village and traveled 20 miles on a heading of 20 degrees. 20 miles at 20 degrees is our first vector. And we're going to write that like this. Next, it says from this point, he traveled 40 miles on a heading of 210 degrees. How far did he end up from the village? So the second vector is going to be 40 miles, angle of 210. So on a coordinate scale, or a coordinate system, what's happening is his start point, or the village, is going to be origin. And his first movement is going to go in 20 degrees at a distance of about 20. Now, from this point where he stops, he's going to go at 210 degrees. So if we were to draw a second coordinate system from that new point where he is, we would have to go 120 degrees from this, or sorry, not 120, 210 degrees from this point. So if we count our quadrants, that's 90, 180, 270, so 210 is somewhere in here. So, and he's going for a distance of 40. So that's 40 and an angle of 210. And then if we count the 90 degree angles from 180, 210 is actually a 30 degree angle. So the resultant, or the addition of the vectors, is going to be where he actually ends up from the origin. So instead of having to compute both of these and draw it all out and figure out where he's at, we're just going to add them. When we add them, that'll give us our answer right here, which would give us a different angle and a different distance. It kind of completes the triangle and tells us where he's actually at. So that's what we're looking for. Now, in order to do this, we cannot add vectors in polar coordinates, which is what they give us. We have to convert each of these to rectangular coordinates and then put them in polar. So, going to grab our calculator. So we're going to get that ready, and we're going to convert each of these to rectangular coordinates. So starting with 20 at an angle of 20 degrees in our first quadrant. So to solve this, our opposite side is going to be our y, or we could say 20 times the sine of 20 degrees is going to equal our u value, and since we're in the first quadrant, they're both going to be positive. So I'll go ahead and type in 20 sine 20 and parenthesis, enter, and that gives me a u value of positive 6.84. Now for the r value, I'm going to take 20 times the cosine of 20 degrees. That gives me 18.79, so that's a positive 18.79 r. Again, to get these equations, I'm just using the trigonometric functions of SOHCAHTOA. If you need a refresher on that, go ahead and go back and watch the video on polar coordinates, grid coordinates, and how to compute opposite and adjacent sides of right triangles. So that's our first one in polar coordinates. We've got 18.79 r plus 6.84 u. Now let's go to the second one, 40 at 210. So if I go to 210, that's actually a 30 degree angle. I am in the third quadrant, so cosine is positive, but sine will be negative. Oh, no, actually, sorry, sine and cosine are both negative. Tangent is positive. And I've got a length of 40. So to find the cosine, I'm going to take 40, or the x value, I'm going to take 40 times the cosine of 30, and that is going to equal a negative r. So on my calculator, let's get the glare out of here. Ooh. I'm going to type 40 cosine 30 and parenthesis, and I get 34.64, and that's going to be a negative value. So 34.64 r. And then for the u, or the y value, 40 times the sine of 30. So 40 sine 30 and parenthesis, and I get an even 20. So 40 times sine of 30 gives me negative 20 u. Now, to find the resultant or add these vectors, I'm just going to combine like terms. So here I see positive 6.84 is going to combine with negative 20, and I'm just going to go ahead and use my calculator for this. So I'll type in negative 20 plus positive 6.84. That gives me negative 13.16u. And then for the R terms, I have negative 34.64 plus 18.79. That gives me negative 15.85. So negative 15.85 R minus 13.16u. Is that how they want us to do this? Hold on. And okay, now for this particular problem in the example, they are okay with us leaving the answer in rectangular coordinates. Now, some problems will tell you to put your final answer, your final vector in polar coordinates. So from there, all we have to do is take these values, if we want to turn them into polar, plug them into our coordinate plane. So we'll go negative 15.85 R, and then we'll go down 13.16u, and we see our vector is going to end up in the third quadrant, so sine and cosine are both going to be negative, and we just use Pythagorean theorem and trigonometric functions to find the hypotenuse and the angle value. So for the length of the hypotenuse, we'll just go ahead and take 15.85, whoops, not negative 1, square that, and then we'll add it to 13.16 squared, and then we'll take that value and we will square root. Let's go up. We get, what is it, 424.41, so we take the square root of 424.41. That gives us a hypotenuse of 20.6. So hypotenuse is 20.6, and for the angle, we're just going to use a trigonometric identity. In this case, we'll say tangent of angle theta is equal to the opposite, which is negative 13.16 over the adjacent, which is negative 15.8. To solve for theta, we're just going to take the tangent negative 1 identity of this fraction. So again, on my calculator, I hit second tangent to get into the negative 1 value. In the parentheses, I put 13.16 divided by 15.85. End parenthesis, enter, and the angle is 39.7 degrees. Now remember that theta value is just in this quadrant right here, so 39.7 degrees plus the 180 from the first two quadrants gives us an actual angle of 219.7 degrees. So the final answer here is going to be 20.6 angle 219.7 degrees. And again, that's only if they want you to put your final answer in polar coordinates. That's it for addition of vectors. If you have any questions, let me know on Moodle, and I will see you in class.